continue with the syllabus and hopefully make up for the shortcomings in the general formula for the geometric sequence in there. So I'm going to give you a sequence and I'm going to start talking about case 1 examples. Right? Now remember case 1, it's exactly the same. We sit with a sequence that is given, and that means that we have at least 3 terms. So in this case we have a given sequence. And that's at least 3 terms, any 3 consecutive terms. Usually it's the first 3 that is given to you. And then the questions that you get related to this, all the questions are just determine the nth term, determine a specific term, determine the number of terms in the sequence itself. And it is solved, so they could ask you determine Tn, determine n for a specific term, you know, write down the value of the constant ratio. That's what they could ask you. And then finally, the types of questions that how you solve this is really with direct application of the formula. Okay, direct application of general formula. Okay. So let's look at that key examples here. I'm gonna start off with a question. I'm gonna make the question 2, 1, and a half. Right? So that's a sequence. The sequence is given. I'm going to pose a few questions here. The first question I'm going to ask you is to determine if arithmetic progression or sequence or geometric progression or sequence. Right? That's question number 1. Question number 2 is going to be determine D or R, depending if it's arithmetic then you will determine D, if it's geometric you'll determine R. Then I'm going to ask you to determine a general formula which is Tn, and then I'm going to ask you to give me a specific term, determine the value of T8. So we're going to do it in that order, right? Now for this to be an arithmetic progression, it means when I move from 2 to 1, I must do exactly the same thing that when I move from 1 to a half in terms of either adding or subtracting. So clearly if I subtract, I'm going -1, and if I go from there, I go -1/2. So it's clearly not arithmetic, so I'm going to take that out, right? It's not arithmetic because I'm not adding or subtracting the same thing each time. What happens when I say, okay, am I multiplying by the same thing each time? Well, 2 multiplied by a half gives me 1, and 1 multiplied by a half gives me a half. So clearly, I have what we call a constant ratio now. Okay? That over there is my constant ratio. So the moment I see that we have a constant ratio, take this term divided by that term, a half divided by 1 gives me a half, and 1 divided by 2 is also a half. If I said a half minus 1, it gives me -1/2, and 1 minus 2 gives me -1. So clearly it's not arithmetic, right? It's definitely a geometric progression. So we can answer the first question over there. Let's just make that question 1, question 2, question 3, question 4. Question 1 is this is clearly a geometric progression. Okay, question 2, determine D or R. So if we have to determine D, it means that we take T3 minus T2 and T2 minus T1, and they must give me exactly the same thing as, but clearly D is not applicable, right? So when we take a half divided by 1, we get a half, and 1 divided by 2, it also gives me a half. So in this case, we determine R. R is equal to a half. Let's do question 3. Determine Tn. Well, it's very, very simple. You just take the general formula for a geometric progression. Tn is equal to A multiplied by R to the -1, and you must do it for this specific sequence. So we need to substitute a value in for A. What is the value for A? A is the first term corresponding to T1, which is 2. And R is going to be the ratio, which we can clearly see is a half. And then we just put there to the power of n minus 1, and that's Tn. Now the last question wants us to determine T8, and that's a very simple case. It's a simple example. All you do is you take the general formula and you change the n's to 8. So we're going to say T8 is equal to A, which was 2, R was a half, to the power of 8 minus 1, which gives me 2 times a half to the power of 7, which is just 2 times 1 to the power of 7 is just 1, and 2 to the power of 7 is 128. Okay? You can work that out. You can check that. And that's going to be 2 times 1, which is just 2 over 128, because this is fractions, 2 over 1 times 1 over 128. And that's going to give me 1 over 64. So that's the first case 1 example. So remember, case 1 is characterized by the sequence being given. We'll ask you about D, we'll ask you about A, we'll ask you about R, and we can't determine D here because it's not arithmetic, right? This was geometric. Remember, when you're going to get a sequence in the examination, it won't be stated what type of sequence you're getting. You're going to have to figure that out. And in this case, we had to test. We had to see, am I adding and subtracting the same thing each time? There's nothing you can add and subtract that is constant, that gives me the sequence. However, there is something that when I multiply, 2 times a half gives me 1. 1 times a half gives me a half. Oh, brilliant. I keep multiplying by half, and therefore this is geometric. Okay. So that's your first example.